Good morning, everyone. This is your first video in English, and in this video we're not going to look at 7.3 actually. We're going to look at the prior knowledge, chapter 7. Let's just abbreviate it with PK. And in the prior knowledge, we're going to basically prepare you for everything that's up in chapter 7. And one of the more difficult things is calculating angles. And that's something that a lot of you already struggle with in chapter 4. And some of you will struggle with it again. So, what did you already learn about calculating angles? There were like tools which you could use to calculate them. Some of them were, for example, a right angle. And a right angle was 90 degrees. And usually when you draw them, it looks like this. Something like that. Besides the right angle, you also had a straight angle. Which was 180 degrees, and it looked like this. This was the straight angle. Last but not least, the full angle, which was 360 degrees. So basically all the way around. If you ignore these three, we're not going to ignore them. There were also two other angles, the acute angle and the obtuse angle, but we're not going to use them yet. I don't think we're going to use them a lot this chapter. Besides these, we also had another tool which we call opposite angles. And whenever you had opposite angles, you had two lines which were straight. They intersected, for example, in point P. Let's give these angle names, P1 up until P4. And if you saw this, then opposite angles basically tell you that angle P1 was the same as angle P3. Same goes for P2 and P4. Those were equal. And now we're going to use these tools in this example. We have this example. I'm going to call this angle A. This is a 1, 2, 3, 4, and 5. And I'm going to give you that angle A3 is, let's say, it's a good estimate of that, 35 degrees. Then we could try to calculate A1, A4, and A5. Why is it that we do not have to calculate A2? It's because this symbol means it's 90 degrees. So how do we calculate, for example, A5? We know that A2, 3, together, and A5 should be equal. Why? Because those are opposite angles. So we can calculate A5 by adding up these two angles, which is 125 degrees. So let's write that down. Then we're going to calculate A1, for example. A1 plus A5 should be 180. Very good, Oscar. This is what is it? Yes, Jens, it's a straight angle. Very good. So A5, A1, you can calculate it by taking 180 and then subtract 125, which is 55 degrees. So we're nearly there. We only have to do one more, which is A4. Does anyone know how we can calculate A4? Yes, Jurgen. Opposite angles, very good. Angle A1 and A4 are equal because those are opposite angles as well. So A4 is 55 degrees as well. Okay, then there is one more thing which is also pretty difficult, and you'll see it a lot in this chapter. If you want to draw triangles, one of the things we had was, for example, we want to draw a triangle ABC, with AB is 5, AC is 4, BC is 3. We could draw this triangle by taking a few steps. Step 1 was starting with the longest side, which usually gives you a horizontal line. That's the easiest way to do it. Draw it as 5 centimeters. Then start with these two lines, and you're going to use these 2 points. You're going to draw 2 circles, one with a radius of 4, one with a radius of 3. So 2 circles and a second circle over here. And you don't need the entire circle, you just have to make sure that they do intersect each other. So this circle was 4 centimeters. This circle was 3, and then they intersect over there, which means that this line is 4 centimeters, and this line is, sorry, this line was 3, and that one was 4, and this was point B, 80. This is something that we also did a lot, so hopefully when you see this comes back. One last thing, which had to do with symmetry. If you're thinking about symmetry, there are 2 types which are important in this chapter. The first one was line symmetry. For example, the letter M. Let's draw a little bit better than this. Letter M was line symmetry, because if you would put a mirror like this, it would give you the same image. Which letter is not line symmetric, for example? Here again. Yes, your first letter, the J. You can't put a mirror in any way to get the same idea. So this one is line symmetric, this one isn't. Are there letters for which there is more than one possible mirror? Yes. If we look at, for example, the H. There are 2 possible mirrors. Then we had rotational symmetry. There were letters that we could turn around. For example, if we're trying to turn around the M, the only way to get the M back as it is by turning it all the way around. So that one is not that one does not have rotational symmetry. Does anyone know a letter that actually does have rotational symmetry? Right now I'm actually trying to think of a name which actually starts with a letter that has rotational symmetry, but for some reason I can't get past the X and the H, and I don't know anyone in your class with those letters as a first. Maybe I'm being really mean right now. I hope that's not the case. I'm actually forgetting my favorite student. The S. Susanna, how could I forget about that? Because if you turn the S 180 degrees around, then it's still the same S. So this one is, that one has rotational symmetry. letter which is not, which does not have that is, for example, a T. The only way to get that is by turning it all the way around. There's one special letter, Oscar, the O. You can turn it in a lot of ways. If it is a perfect circle, for example, then it has an infinite amount of possibilities. These are basically the three things that we already talked about, which you'll need in this chapter. If you have any more questions, just let me know.